Okay, now I will present the PSDA project 2. This is our project. From the data set, we count up the 6 variable. Then we do the data analysis. We use the hypothesis 2 sample test, which is mean 1 is equal to mean man and mean 2 is equal to mean woman. We do the hypothesis statement test. The null hypothesis is mean 1 equal to mean 2. Alternative hypothesis is mean 2 none equal to mean 2. We do the calculation to get the mean 1 and mean 2 and standard deviation, and we use the RStudio to obtain the t value, and we have degree of freedom. Then we count up the p value. Probability of value is 1.425 power of negative 45. Since we can conclude that p value is more than cynical value, which is 0.05, so we reject the null hypothesis.
Good afternoon, everyone. Now I would like to present correlation and regression part for our project. The x variable is age and y variable is salary for correlation, and this is scatter plot. We want to test the linear correlation exists or not. And first we find the r equals 0.269, which is a weak weak correlation relationship between two variables. And we find out that T0 is 3.925, p-value is 0.00012. Okay, our critical T is 1.97, and since T0 is larger than T critical and p-value is smaller than 0.05, we reject hash null. Thus, there is sufficient evidence to support the existence of relationship between edges and salary, where since it is positive linear, so when edges increase, salary increase. Okay, next for regression, our x is year of experience, y is salary, and then we want to test linear relationship between them. Okay, first we find b0 and b1, and then we form this regression estimated regression model, and we find out that t0 is 14.2 at 3, p-value is this, and then find out the t critical. Okay, since t0 is larger than t critical and p-value is smaller than the significant level 0.5, we reject hash null. Thus, when the year of experience increase, salary increase. Okay, because it is positive linear relationship due to the positive gradient. Okay, that's all from me. Thank you.
Okay, now I'm going to present the last part of our project 2. So I'm going to start with the chi-square test of independence, and the variable we tested here is the education and the salary. Okay, so based from the test, right, we get the p-value, which is p-value is equal to 2.2 times 10 to the power of negative 16, which is very small and smaller than the alpha value we tested here, which is 0.001. So that we reject the null hypothesis, so that actually there are sufficient evidence to support that the salary are actually depend on the education level of the worker. And for the ANOVA test, we tested on the job title and the salary. So the conclusion here is that the p-value we got is 2 times 10 to the power of negative 16, which actually essentially is 0, so that in conclusion, the p is less than the alpha value we tested, which is 0.001. So we reject the hypothesis null, so that the result indicate that the job title have a significant effect of the salary, which there are significant difference between in salary between the job titles.